Number 11. 1 year, the mean age of an inmate on death row was 41.6 years. A sociologist wondered whether the mean age of a death row inmate has changed since she randomly selects 32. Since then. She wants to know if it's changed since then. She randomly selects 32 death row inmates, finds the mean age is 39.9 with a standard deviation of 9.6. We're going to do a 95% confidence interval. And what does the interval imply? So we want to know if it has changed. So that's two-sided, left or right. We don't know bigger or smaller. So the mean age was 41.6. We now want to know, has it changed? So is it not equal to 41.6 anymore? So whether bigger or smaller. 95% confidence interval. Stat T, one sample summary. Sample mean was 39.9. Standard deviation 9.6. Sample size was 32. So we got approximately normal, random selection, independent. The mean was 41.6. And we want a 95% confidence interval. So we think the true mean should be between, around the two decimal places, 36.44, the low end, 36.44. The upper end is 43.36. Based on the confidence interval, the mean 41 is in between these numbers, so it could be the true mean, so it's possible that it hasn't changed, so we will not reject the null. So since the mean age is contained, there's not sufficient evidence to conclude that the mean age had changed. A. All right, number 12, 5 parts, last one. The mean time at the drive-thru of a fast food restaurant from the time an order is placed to the time the order is received is 86.1 seconds. A manager devises a new drive-thru system that she believes will decrease the wait time. We're going to test. So as a test, she initiates a new system at her restaurants and measures the wait time for 10 random selected orders. The wait times are provided in the table to the right. We're going to complete parts A and B. So because the sample is small, the manager must verify normal distribution and that it doesn't contain outliers. So the normal probability plot is shown. The correlation is R equals 0.982. Are the conditions for hypothesis test satisfied? So normal probability plot shows roughly a straight line, so that's good. The R needs to be greater than the statistic. So we're going to go look at the critical values for a correlation. It needs to be, if this is greater, we are good to go. We have 10 in our sample, so we're going to go to sample size 10. That gives us 0.918. And since 982 is greater, normal conditions are satisfied. So yes, conditions are satisfied. Is linear enough? Correlation coefficient is greater than, and there's no outliers. All right. Mean equal. And she said that she thought that it will decrease, so mean it's going to be less than. All right, we're going to do test statistics. So we don't have the mean and standard deviation. So we're going to go to Excel and find the mean and standard deviation. So in this data, I'm just going to come over here and just say MU for mean, and in this column I'm going to say S for standard deviation. So we're going to go to formulas, more functions, statistical. We're going to find the average first, and it shows A. We're going to click this array. It's already computing it for us right here. So our sample mean is 79. We're going to go statistical, and we're going to go all the way down there in alphabetical order looking for S for standard deviation right here. There's two of them. This is population, this is sample. We want the sample using the T. We're going to click and drag and copy this array again, and it's already computing. And so we get our values that we need. So from there, we can use our T statistic. The sample mean is 79. Sample standard deviation is going to be, to 2 decimal places, 15.2. Let me put the whole thing in. It doesn't matter on here, so I don't want to round to the end. The more times you round, the more it throws off your answer. We had a sample size of 10. The mean wait time for an order was 86.1. And we are testing that it's less than that now. We don't have a level of significance yet, but our T statistic, negative 1.49. P-value roughly 8%, 8.5, so between 5 and 10. If we are testing at 1% level, 8 is greater than that, so we will not reject the null. P-value is too big. P-value is greater of significance, so there is evidence. Nope. P-value is greater than level of significance. There is not sufficient evidence to conclude the new system is effective. Correct.